All right, this is the video for chapter 3. Instead of doing the video for the whole thing, what I'm going to do is do a few problems, and then have you do a few problems, all right? So on problem 1, for each expression, we're going to determine if the polynomial is better known as factors or terms. We're going to list the factors or terms, and then we're going to put the form that it's in, so standard, factored, or vertex. So that's actually where I'm going to start, is if it's in standard, factored, or vertex. So when I look at the first one, these are a bunch of neighbors seeing each other. And if you have your flip book, you're going to see on the back that this best matches standard form. Factored form. Okay? So that means there are not terms in there, that they are instead factors. And the factors, one factor is x, another one is 2x plus 1. And another one is x minus 4. So I'm just going to separate them by quite a bit just to show that I have 3 factors. Okay? So for instance, if you look at C, this is best noted as vertex form. Vertex form usually does not have factors. So what I want to know is, do you know what the terms are? There are 2 of them. So put one here, and then put the other here. Definitely separate them for me. I'm going to leave B up to you. And now I'm going to move into number 2. So on number 2, the main thing I'm going to do and walk through with you is the whole adding the opposite. But pay attention to which problems are neighbors and which are not. So first, the neighbors problems are not 2 or A and B, because there's a plus and a minus in between them. But C is a neighbors problem. And D is a neighbor's problem. And E is a neighbor's problem once you write that x plus 6 out twice. This is very similar to a mile marker problem. F is a neighbor's problem. And G is a neighbor's problem. Boy, there's a lot of neighbor's problems on here. And then we're going to do H from beginning to end. So working through left to right on A, I'm going to add the opposite. And the only subtraction I hear is the minus 2x. It only applies to this, so I'm going to add and the opposite. On this one, left to right, I'm going to add the opposite. And then here, this is where we tend to mess up. The subtraction is for everything in the parentheses. So I'm going to add the opposite. And then I'm going to come back, and the subtraction applies to the 3x, so I'm going to add the opposite. And then I'm going to come back, because since the subtraction also applies to the 2, I'm going to add and the opposite. And now you're ready to combine them. So for instance, you'll combine your x squareds, and 2 and negative 5 means you have negative 3x squared. And then when you're done, you will want to classify this. So when you classify this, remember, you're going to have a first name and a last name, and you can look in the top left of your flip book for that. So letter C, left to right, I'm going to add the opposite. On D, I'm going to add the opposite. E does not have it, but F does. I'm going to add the opposite. G does as well. I'm going to add the opposite and add the opposite. And H, and then we're actually going to do H together, so add the opposite. And this is one of those kind of unique problems. And I am going to hold off on the subtraction of adding the opposite. So what I want us to look at is that we have a neighbor situation happening here. And if I put this over here, and actually let's just change that to a plus instead. So we're just changing the problem. And over here, I have another neighbor situation that's happening. So what I'm going to do is go over here and have these neighbors meet. And then I'm going to come over here and have these neighbors meet. So first, starting with these neighbors, I'm going to have x go and visit first. And I get x squared and a 3x. And then I'm going to have the negative 2 visit. So I'm going to get a negative 2x and a negative 6. So I'll stack the negative 2x here and put the negative 6 there. And when I'm done, the neighbors in red are x squared plus 1x if you want the 1 plus negative 6. Now I'm going to come over and let these neighbors meet first. So x is going to visit first. And I'm going to get x squared and 2x. And now the 2 is going to visit. I'm going to get another 2x, and then by multiplying, I get 4. And when these neighbors are done, I'm going to get x squared plus 4x plus 4. Now what's happening is there is an addition adjoining these neighbors. So we'll put in parentheses. There's that plus sign and these neighbors. And now the problem is just like, like 2a or 2b. So first I'm going to join the x squareds. And that's like a 1x squared and a 1x squared. So I get 2x squared. And now I'm going to let the x's meet, 1x and 4x, and that's 5x. And then I'm going to let the plain numbers meet, -6 and 4 give me -2. Now to classify it, this gives me its first name. It's quadratic. This is our popular kid. And then with the 3 terms, I would call it a trinomial. If you would like to on the test abbreviate it as QT, you are more than welcome to do that. All right, I think I'm going to let you try the rest. You should definitely check out the answers as you're going through, and if you don't get the answers, you come up and talk to me. All right, so on 3 and 4, I have a box that I'm going to do, and then I want you to try a box. So the idea is I need to come up with 2 quadratic trinomials. So the good thing about this is over here, that's a QT. I know what a quadratic trinomial is. This is an example. I just might have different numbers. So I need to have, 2 quadratic trinomials so that when I add them up, I get a linear monomial. Okay? So again, a quadratic trinomial might look like this. So x squared plus 3x plus 4. And so I'm going to have another one right below it. Okay? And then when I'm done, I want a linear monomial. A linear means that the highest power is 1, and that a monomial means I'm only going to have one term. So again, a linear means, might just be like 4x or 3x or 7x or -4x. And a monomial means this is my only term. So the idea is I want to add these up so that when I'm done, I only have one thing here and nothing's here. So if I'm adding these, the only way to add to x squared and get nothing left is to add a -x squared, because those would cancel out. And the only thing to add to 4 so that it went away would be a -4, because those would cancel out. So by doing that, I'm going to be sure that when I'm done and I add up, I just have something like this. So I could put whatever I want here. I could put 4x, 5x, 7x, -3x, oh no, not -3x, sorry, but I'm going to put -5x here. I wouldn't put -3x because then it would just disappear. So when I'm done and I add them up, this is a linear because there's a power of here, and then there's only one term, so that makes it a monomial. So what I want you to do is write something a little similar, but I don't want to see exactly the same thing here, and try yours. All right, the next one, I'm going to get an example of 2 linear binomials. So linear, again, means that the highest power is 1, but that I then have 2 terms. So here's an example of 1 linear binomial. And then in another linear binomial. And when I multiply these, I'll get a quadratic trinomial. So just so you guys know, anything that looks like a factor and a factor like we've been doing is going to get us to the QT. So for example, these were 2 linear binomials. This is a linear binomial and this is a linear binomial, and when I multiplied them, I got a QT. And then the same thing here, even though they look the same, I got a QT. So you just need something like that to come up with this. And these are not easy questions, but you just kind of try and learn by example. So first I'll meet these, and I get 2x squared the first time, and then I get a 1x, and then these neighbors meet, and I get a 6x, and then a 3, and when they're done meeting, here's my QT, 2x squared, 7x plus 3. So now you come over here and try something very, similar but different. All right, I'm going to now jump to number 6, and I'm going to do this one, which is similar to this one, and this one, which is similar to this one. So what I need to do is find what's that missing term that would make a perfect square trinomial. So again, that perfect square means that whatever this side is, this side is. I can make them negative 7s if I want. That doesn't matter. So the idea is I could write them twice, or I could write them once squared. So this is very similar to that whole thing that we did of completing the square. What's that missing term? So I'm actually going to start with B because I think that's the easier one. So remember, if you take 12 and you cut it in half, you get 6, and 6 squared is 36. If I factor this, if I actually take the time to factor this, so here we go, just to show you why, again, this is working. Here's the top. There's the bottom. I would use my factor program or factor list to see that those are the numbers. Then I would rewrite it. And when I rewrite it, I think I'm going to go up here, I'm going to have x squared plus 6x plus 6x plus 36. And then I'm going to group them. Remember, you can always pause. And then here I do a GCF. There's not a number to take out of both of them, but I can take an x out. And then x times x is the x squared. X times 6 is the 6x. And then these always match, so there's another x plus 6. So what times x is that, or what times 6 is that? That's just another 6. And then you'll get those identical parentheses of x plus 6 times x plus 6. And that's a perfect square. So here we're doing it backwards. Basically what happened is they took a number and squared it to get to 25. And hopefully we would all realize that's 5. And then what's the number that they cut in half to get to 5? And that's a 10. And so I would just want to remember to put a 10x with it. So 10 cut in half is 5. 5 squared is 25. So now you're going to try these. Just note that this is a negative 24, so maybe you want to add the opposite on that one. Okay? All right, moving along. Let's go to problem 7. We are going to do some factoring. So the first step of all factoring, it does say completely, so in my flip book says I should do a GCF. So when I look here, what's the biggest number that goes into 6 and 18? That's a 6. I look to see if I can take an x out of both of those, and I can't. So 6 times what gives me that? That's an x. And 6 times what gives me 18? That's a 3. Now factor completely says I should look at what's left to see if I can factor it some more. This is 2 terms, so what I would want to see is this the difference of squares. Well, what I notice is 3 doesn't have a perfect square root, and this needs to be x squared to have a perfect square root. So as it turns out, factoring the GCF is all I could do here, and I'm done. So let's go to F. First, I'm going to look for a GCF. So there's no number besides 1 that goes into 3, 7, and 6. And they don't have an x, so I'm going to skip the GCF. But since there's 3 terms, I'm quickly adding the opposite. I'm going to make my x. So I loop, and there's the top. And I circle, and there's the bottom. And then I would look at my factor list of 18 to figure out what numbers would also get me to 7, and that would be 2 and 9. And since that's negative, as Alyssa has pointed out, that's going to make the bigger number negative. And sure, maybe you want to add these just to make sure and multiply these so you get those. But now we're going to rewrite it. So we're going to rewrite this, but instead of that version of circled, we're going to have that version of circled. And then in our flip book, it says we do the parentheses part, and then we do the GCF. So first I'm going to look what's the number that goes into both 3 and 2. 1. If you want to take the 1 out, you can. But what I really want to focus on is that I can take an x out. So x times what gives me 3x squared? That's 3x. And x times what gives me 2x? That's a 2. And again, remember, these are going to match. So the other one is a 3x plus 2. And so I'm trying to figure out what we took out. So what times 3x is that? That's a negative 3. Because negative 3 times 3x is negative 9x, and negative 3 times 2 is negative 6x. And now I've got my factors. One is the matching set of 3x plus 2, and the other is the things on the outside. You can do minus 3 or plus negative 3. That's up to you. All right, next problem we're going to talk about is number 8.